Ryan Electronics is comprised of a number of closely integrated activities. It has been engaged for 14 years in the research, development, and manufacture of electronic products for aircraft, missiles, and weapons systems. The engineering facility, located on San Diego's Kearny Mesa, conducts research and development in numerous areas, including radar systems and techniques, digital and analog data processing, and magnetics. This facility has concentrated design effort in missile guidance, aircraft and helicopter ground velocity sensors, altimeters, landing aids, IFF equipment, and ASW weapons systems. Important advances are being made. Further development also is continuing in the field of navigational computers and indicators. Radar altimetry techniques developed at Ryan are evaluated at one of several Kearny Mesa microwave testing ranges. The microwave laboratory includes a modern boresight range, as well as the most up-to-date facilities to work with frequencies ranging from VHF to Q-band. A complete environmental test laboratory includes equipment which was specifically designed for physical tests of development, prototype, and production components, and complete electronic and electromechanical systems. Low and high-frequency vibration tests are conducted within a soundproof area. Such tests also are conducted in absorber cones to permit microphonic testing of microwave radiation devices. Interference testing to meet military requirements is conducted in a shielded room. Systems engineering provides pre-installation evaluation. Successful field tests were conducted on complex terminal guidance systems, including extensive ground-aware and air-to-air flight investigation of simulated missions. Extensive navigational systems tests have been conducted at the Kearny Mesa facility. This 20-acre site is equipped to handle rotary wing aircraft. Other Ryan Electronics facilities include the manufacturing plant, which is located adjacent to the Torrance Airport near Los Angeles. Here, specialized facilities and assembly areas have produced equipment expressly designed to meet the requirements of Army airborne missions. For many years, Ryan engineers have been actively engaged in flight test programs for automatic navigators and in evaluation of navigational and flight instrumentation systems using continuous wave Doppler techniques. The Doppler effect is a natural phenomenon which has long been neglected. To provide a coupling to the ground, the microwave energy generated by the CW Doppler set is concentrated into narrow beams of radiation. A portion of the energy is transmitted along each beam at frequency FP. Energy is reflected back into the antenna at frequency FR. The reflection of energy results from dispersion of the incident energy caused by the roughness of the Earth's surface. With beams directed aft, the frequency of the reflected energy is lower than the frequency of the transmitted energy because of the component of the aircraft's speed relative to the ground along the direction of the beam. The difference in frequency is proportional to the component of aircraft speed along the beam axis. The higher the aircraft speed, the larger the frequency difference. This frequency shift phenomenon, known generally as the Doppler effect, is the basic principle used in Doppler ground velocity sets to measure the speed of an aircraft in flight. With one microwave beam, only one component of the aircraft's speed can be measured. However, with two beams and barometric altitude data, it is possible to compute the aircraft's heading speed, drift speed, ground speed, and drift angle. The flexibility of Ryan products is exemplified by the APN 129B navigation set. This system was conceived to meet specific requirements of Army aircraft. This system comprises a ground velocity indicator group and a vertical reference group. It computes and displays ground speed from 50 to 300 knots and drift angle from 0 to 45 degrees right or left. The navigation set provides this information automatically, continuously, and accurately, without other navigational aids or wind estimates. The equipment is completely self-contained. The system's antenna is so compact that it can be housed in this small tail cone of the Army's RL-23D reconnaissance aircraft. Because of its rigid flush mounting, the installation does not increase aerodynamic drag. The altitude coverage of the set is 0 to 25,000 feet. It measures ground speed with an error of less than 1% and drift angle with an error of less than 1/2 degree. Doppler sets provide instantaneous, highly accurate ground speed and drift angle data under all weather conditions anywhere in the world. Distance traveled, distance to destination, and the aircraft's precise position in latitude and longitude also are provided in certain versions of the APN 129V. In rotary wing applications, CW Doppler provides a visual concept of local navigational status and indication of helicopter velocities in reference to the ground. These systems provide instantaneous information over all types of terrain and under all weather conditions. The ability to fly within the concealment of ridge lines, ravines, wood lines, and other terrain features offers the air mobile unit the same protection that has always made the ground the soldier's best friend. The need for mobility in the Army's striking force is placing additional emphasis on aviation, both rotary and fixed-wing aircraft. To meet the stringent operational and environmental requirements necessary to provide the Army Sky Cavalry with increased flexibility in combat areas and to provide accurate navigation for nap-of-the-earth tactics, Ryan Electronics Research is programmed to continually solve today's airborne navigational problems in all categories. In maintaining its position as a pioneer in the constantly advancing frontiers of electronic technology, Ryan Electronics will continue to have the answers for the missions of tomorrow.